So we're going to look at the formation of the global atmospheric circulation step by step. Now the first point to remember is it's all about the amount of radiation and energy from the sun. We do not get heat from the sun, we get radiation, shortwave radiation. And it is this, when it hits the planet, that then causes the ground to warm up. Now at the equator and around the equator, the sun shines straight down at it. So therefore, when it lands on here, you can see there it would shine on a very small area, so the sun's energy would be very concentrated. As we move up to higher latitudes, the sun would cover a much bigger area, and so the energy would be far less concentrated. Hence the reason that the land would heat up far more around these equatorial areas, which leads to heating the air above it. Do not make the misconception that it's about being closer to the sun. If it was about being closer to the sun, then the mountains would be hotter, and that is not the case. So it is about the angle at which the sun shines down and hits the surface of the planet. Now what we can see then at the equator is the sun shines straight down, and so there's a lot of heat energy being released by the land. Now because of this heat energy, it then forces the air to rise. Now as it rises, you've got more air being pushed in from here, from down below, and continuously rising. Now the air can't keep rising forever because it's locked within the troposphere. So that means as more air pushes up, it starts to push it to the side like this, and it does the same going the other way as well. Now as the air is being drawn up here, it's also going to draw in air from the sides, which we can see here. Now because the air is rising, it cools high up, and as it cools it condenses and creates clouds, which then create rainfall. So we tend to get a lot of rainfall at these equatorial areas. Now as we've started to get this bit of a cycle flowing here, the air eventually, when it's away from the rising air at the equator, it's been pushed to the side, and then it starts to fall back down again, because it's all about trying to balance the pressure out. This low pressure area caused by the rising air is drawing air in and sets up this circulation cell. Now at each end of these cells, because the air is sinking, it's warming, it means the clouds disappear, and it means we get a lot of sunshine here. And there we go. So this is the first circulation cell, and these are called the Hadley cells. And what these lead to is the fact that around the equator we get low pressure systems, which lead to lots of cloud and rain, but warm temperatures virtually all year round. As we move out and we move towards the tropics, because the air is descending, it's creating high pressure. This means there's very little cloud, so the sun shines straight down on it, but it also means that there's a lack of rainfall there. So we're now going to have a look at the poles. Now we know at the poles the sun's energy is very, very spread out, and also for times of the year the sunshine only shines for a few hours, and at some points it can be in complete darkness or night time for several months. So this makes it extremely cold. Now because it is so cold, that means that what we have is a lot of very cold air, and we know that cold air sinks. So what this means is the air, as it rises, it comes above it, it starts to sink down. Now because of this high pressure system that we're getting here, so we've got a high pressure on both of these, which means descending air, and as the air keeps descending, it means this cold air is then forced down. again setting up these circulation cells. So more air becomes drawn in to the poles to replace that sinking air, and this gives us the start of the circulation cell. Now, so this is the start of the polar cell that we can see here. So we have this cold air from the poles sinking down to mid latitudes or temperate areas, and this sets up another circulation cell. And because we've got this circulation cell, we're then going to start to see air rising here as well to replace the air that is at the side that is being forced over here. Now this works in conjunction with the ferrule cell, because as the air is sinking here, not only does it return to the equator, so the air sinking at the tropics returns to the equator, but the warm air also pushes up towards these higher latitudes that we can see on here. Now this gives us a battleground between the cold air coming down from the poles and the warm air rising up from the tropics. Now, because the warm air is less dense than the heavy cold air, it means that this warm air rises above it, as we can see here. Now, not only that, this means that we have low pressure systems starting to form here. Because the air is rising, it's drawing more air in from the side. And because we've got low pressure, we're then going to start these rain clouds starting to form here. Now again, we've got to close off this circulation cell because the air is all going to return. And this is what creates the ferrule cell here. So we now have these three different cellular systems within the atmosphere. So just to recap then, we know that rising air, which is found around the equator because of the concentrated sun's energy, mean that the land heats up more, creating the air above it to warm, leading to this rising air and low pressure. Because there's low pressure here, that means then the air is drawn in from the side, creating the winds on the surface. This, as the air rises, then leads to the condensation of water vapor, leading to cloud and rain, which is why equatorial areas tend to be hot and wet because of the low pressure systems, and this is formed around the area where the two Hadley cells meet. Where the Hadley and the ferrule cell meet, there is descending or sinking air. This means that the water or the condensed water turns back into water vapor, meaning few clouds and little rain. So it is fairly sunny and bright all year round, and it is known as a high pressure area. As we move to the area where the cold descending air is forced down at the poles towards more mid-latitude temperate areas, it meets and battles with the warm air coming up from the tropics. This leads to the colder air forcing its way under the less dense warmer air. This means the warmer air rises, which then leads to low pressure, clouds and rain. And this explains, at our latitude in the UK, why we get these wet and windy conditions as we're under the low pressure. At the high pressure areas, the air tends to be much calmer and less powerful winds there. The wind is at its greatest around these low pressure systems. So these are the key basics that you need to understand on the tricellular global atmospheric circulation. You need to know the reasons why the air moves in these different patterns. You also need to know the type of pressure, low or high, and the weather and climate conditions that these can lead to. The other thing to note as well is that it's really important to recognise the way that the wind moves around. Now we know that at the low pressure equator the air is going up, and so the air is drawn towards it to equalise the pressure. However, because of the spin of the Earth and the Coriolis effect, it means that the winds get deflected off. So we don't get the winds going directly to the equator, they veer off. So here we notice this direction that they're going, and then once you get into the Ferrel cell, they go off in the other direction. And this really helps to explain why the prevailing wind direction in the UK, where we are here, comes from the southwest. It also explains why much of our weather comes from the southwest, as it blows the weather systems over us. And we also get this cold air coming from the north, meeting from the warm air from the south, which leads to these spells that we get of clear weather. Then we will have some rainy weather, followed by showers in a bit of a warmer spell of temperatures, and then we'll have another band of rain, followed by the cold air, but we'll do more of that later on. So this is another key part of the circulation cell system. Now, probably best to stop there, but if you do want to know a little bit more and see how even more complicated it gets, then you can keep watching. Or you can just pause it now and write up these notes in your book.